Okay, today's class, this is topic 3. We're going to talk about erosion today. So what is erosion and how does it differ from weathering? So two terms that we need to know. Erosion is the movement of rock and mineral grains from one place to another. Okay, so it's moving. Weathering, on the other hand, is the process in which rocks are broken down and sediment gets formed by either mechanical, chemical, or biological means. So basically sediment, it comes from those larger rocks that have broken down or worn away through weathering. All right, and then erosion is the movement of those sediments. Okay, so the first type we're going to talk about is mechanical weathering. This is the physical breakup of or disintegration of rocks. So gravity can cause rocks to fall down a cliff. They'll break apart. Rocks that are rolling down a slope or in a fast moving stream, they'll rub and bump against each other. They'll become smoother. They'll become more rounded. So wind and water can also wear away surfaces of rocks and then carry the pieces to another place. When we talk about sedimentation, this is the process in which eroded material is deposited and built up. All right, so here, this is a figure we're looking at showing many thousands of years of rain, wind, and ice have eroded this rock, and this is from Alberta's Dinosaur Provincial Park. Here we can see that temperature change can also cause mechanical weathering. So there's something called frost wedging. So this is a process where water goes through a cycle of freezing and thawing. Water will therefore expand and contract in the cracks of a rock and eventually causing the rock to break apart. So during this freeze-thaw period, snow and ice, they melt in the daytime, allowing water to seep into the cracks in the rock. And then at nighttime, the temperature falls below 0 degrees Celsius. The water will freeze and expand. It'll push the cracks wider apart, which will result in the rock breaking apart. Okay, so it's a repeated freeze-thaw period. Okay, so water that will repeatedly freeze and then thaw. And that's what we're seeing here. So water seeps in that crack. It'll expand. It'll widen the crack. Eventually, that rock piece will break free by fracturing. Next type of weathering. This is chemical weathering. This is the breakdown of minerals through chemical reactions. So these chemical reactions, they can speed up the process of erosion. Material may get dissolved. Material may get weakened. Rocks will react with water and with other chemicals that are dissolved in the water or even with gases in the air. So for example, acid rain. It contains dissolved chemicals from air pollution. That acidic rainwater, it will react with some rocks such as limestone and dolomite. And then that rock material may dissolve easily in that acidic water and then wash away. So here we're seeing how some old buildings, statues have suffered through those effects of acid rain. This is the Parthenon in Athens, Greece. Next is biological weathering. This is the physical or chemical breakdown of rock. It's caused by living organisms. Okay, so biological meaning living organisms. So things like plants, animals, bacteria, and fungi. So there's a physical breakdown. That's like a plant root wedging into a rock by forcing its way into a crack. And then as that root grows and expands, so does the crack. The rock will get pushed apart until it will eventually break apart or crumble. So that's a physical example of biological weathering. There's also a chemical example here. So things like acidic fluids that are produced by plant roots or bacteria or fungi or some insects and small animals can also cause chemical reactions. So as the rock slowly dissolves and flows away with rainwater, and cracks and crevices will increase in size until the rock will finally break apart. So this figure here is showing tree roots working their way into cracks. As they grow, they'll eventually break up the rock. All right, so I'm going to pause here and just put on a video here. What's the difference between weathering and erosion? All right, so next, the changing surface of Earth. So glaciers, gravity, wind, and water are agents of erosion, just like we saw in that video. So a gradual change is when changes happen very slowly over many thousands of years. For example, changes that are caused by glaciers. Glaciers form by the weight of layers of snow piling up year after year. And then when glacier ice spreads out over the top of a slope, the force of gravity causes it to start flowing down the slope. And then as glaciers pass over land, they start to erode it and change its features. So rocks that are frozen in the glaciers, they can start to scrape across bedrock. They'll wear it down and they'll make these scratches called striations. Eroded sediments get pushed in front of a glacier and piled up along its sides. Those are called moraines. And when glaciers begin to melt and retreat, that meltwater forms channels and it deposits sediment in new locations. Large rocks that are called erratics can be left behind many kilometers from their source. There can also be a sudden change. This is when changes occur very quickly, like flash floods, landslides, and rock slides. This was the example I was showing about striations. So again, when glaciers are scraping across bedrock, they wear it down and they make those scratches. That's shown here. Those scrape marks are called striations. They indicate the presence of a glacier. Here, as the glacier advances, rocks and sediment and trees get pushed along right in front of it. This is an erratic. It's called the Big Rock. It's near Okotoks, Alberta. It was left behind by a glacier. It might be the largest erratic in the world. This is showing moraines. Those are the great piles of sediment and things that are pushed aside by a glacier. This is in Banff National Park. Gravity, it's one of the forces responsible for landslides and rock slides. Retaining walls can be built. Drainage can be improved. Dangerous slopes can be monitored. Wind can also erode rock particles. So when it blows across dry ground, it picks up loose sediment like clay, silt, and sand. These wind-blown particles, they can strike rock. They can wear it down by abrasion. Abrasion is the wearing down of rocks by wind or ice or waves and running water. Extreme examples of wind erosion include sand deserts. So again, wind erosion can be slowed or stopped by planting lots of vegetation, contour farming, or reduced tillage. This was a rock slide here. It was called the Frank slide. Over 80 million tons of rock crashed down the side of this mountain. It buried part of the town of Frank, and more than 70 people died in this disaster. And that slide lasted less than 100 seconds. So that was the Frank slide. Water in motion is one of the most powerful causes of erosion. Sudden changes can occur as rivers erode their banks, and fast-moving floodwaters carry away large amounts of soil. Heavy rain can disturb the stability of a slope, detaching solid blocks of rock. It can cause landslides. Oceans and seas and large lakes can erode their shorelines. When waves hit cliffs and shores, rocks are broken down, land is getting eroded. Slower changes can happen as well. As streams and rivers carry rock fragments along in the water, those fragments will rub against each other and the riverbed as they're bounced along, and they will gradually get rounded and worn down. So rivers can cut straight into rock. They can form canyons or gorges and these V-shaped valleys. And eventually the sides of the valleys will get worn down by weathering. When a river becomes mature, it cannot dig its channel any deeper. It might start to meander, meaning curving its bed from side to side. All right, this here, Athabasca River near Jasper. It's gradually deepening the quartzite rock canyon. Here we have a meandering river. It continually changes the contours of the land. Here, a melting glacier, over 1 million years of melting glacier water has dissolved deposits of limestone. This is the Castlegar Cave. It's an enormous cave. It's more than 18 kilometers long, located near the Columbia Ice Field in Banff National Park. All right, so we're going to stop here. We'll watch a couple of these videos.